Hello everyone, I hope you all are doing great. Today in this video we will discuss pressurization system of Airbus A320. It will be a video of journal overview. It will not be a detailed video. If you want to watch detailed information about the pressurization system of Airbus A320, you can check out line to line explanation of FCOM of this system. I have made separate videos of each system in which I have explained the whole FCOM line by line, word to word. Right. In this video, we will discuss fully automatic mode, semi-automatic mode, and the manual mode of the pressurization system. I will let you know what all instruments are involved, what all systems are involved in the pressurization, and in the end, I will tell you how the CPCs changes and from where I have taken this information from the FCOM, right? Let's start. But before starting, disclaimer, I do not own any of the image and content used in this course. Of course, it is just a reproduction of Airbus manual, official documents, or images from the Google, just to serve the purpose of easy understanding of the system, procedures, and the topics. I request you to keep this video at 1.5 or 1.25 to reduce your watch time, and obviously my rate of speech is very slow, so it will help you. If you find any incorrect or inappropriate explanation of any topic, please let me know in comments. I will be definitely looking forward for your suggestions, or if you find this video helpful, please let me know in comments. I don't ask you to subscribe but to comment, because it tells me whether either I'm doing good or not, right? So let's start with the pressurization system. It is made up of two identical independent automatic systems, system number 1 and system number 2, to control the cabin altitude. The overall system consists of two CPCs, one outflow valve and one safety valve. So outflow valve is placed on the right side of the rear fuselage and safety valve is placed on the rear bulkhead. This is this is how outflow valve looks like, and this is how a safety valve. There are two safety valves on the rear bulkhead. You can see over here, if you can imagine a fuselage without APU from behind, there are two safety valves, right? Okay, they all are they all helps to pressurize the aircraft. The outflow valve actuator incorporates three electric motors, two for automatic control and one for manual backup, right? In normal operation, the system is operated in fully automatic control. However, it can also be operated in semi-automatic or manual control. The CPC receives the landing elevation, destination QRH from the FMGC, static pressure or baro references from the ADIRS, and flight or crew or ground information, flight or ground signals from the LGCIUs. So all these are helpful to pressurize your aircraft, and even in fact thrust lever angle is taken from the EIUs, right? So they all are helpful to pressurize your aircraft. EIU stands for engine interface unit, LGCIU, FMGC, ADIRS, and even emergency ram air input is taken, right? So this is how with the help of all these things your aircraft gets pressurized. This all information goes to CPC, and with the help of the combined information, CPC pressurizes the aircraft, right? In case of FMGC failure, the crew sets the landing elevation manually by pulling the landing elevation knob out of the auto detent and selecting the desired landing elevation The system then uses its own internal pressure schedules. This is called semi-automatic function, semi-automatic control. In this case, controller uses the captain's barrow reference from the ADIRS. Now, if in case, okay, in automatic control, the CPC takes information from the FMGC. Before starting flight, you have given everything to the MCDU, and the information goes to FMGC. But if in case FMGC fails, now CPC want to be having landing elevation information. So in this case, your pressurization system changes from fully automatic to semi-automatic mode. Now in this scenario, you will have to put your landing elevation, means landing elevation of your airport where you are going to land. This helps to schedule your pressurization. It automatically, aircraft then automatically figure out when to reduce cabin pressure or what pressure it should maintain at what altitude, right? This is how it takes information. Now if in case you wants to change to it to the manual mode, the crew controls the cabin altitude by the use of switch control on the cabin pressure panel. You press this push button and this whole system goes into manual mode. Then you pull up or pull down this toggle to open or close your outflow valve directly, right? Keeping it to up, it will increase the cabin altitude, and pulling it down, it will reduce the cabin altitude. This is how this system works in manual control. Okay, one more thing, in semi-automatic control, your landing elevation will be given from this knob, and the barrow ref will be taken from captain's barrow reference, right? Now I have explained fully automatic, semi-automatic and manual mode. I would like to add one more thing over here. The safety valve prevents cabin pressure from exceeding 8.6 psi and -1 psi below ambient pressure. These safety valves prevents 8.6 psi and -1 psi. Generally, cabin delta P remains 8.06. There is difference. Generally 8.06 is the delta P, but this safety valve prevents reaching 8.6 psi and -1 psi. Right. Now I will discuss automatic pressure control sequence. In automatic mode, how aircraft pressurizes automatically itself on ground during takeoff, cruise, descent, and during abort takeoff. So I will clear one thing here only. I have taken most of the things from the FCOM. They all schematic diagrams and everything is from the FCOM only, and these images are from the Google, just to give you a easy understanding, to explain you easily, right? So I was telling you about the automatic pressure control sequence on ground before takeoff and 55 seconds after landing. On ground and 55 seconds after landing. This is here the aircraft lands, and 55 seconds after landing, the outflow valve fully opens to ensure that there is no residual cabin pressure. At touchdown, any remaining cabin pressure is released at cabin vertical speed of 500 feet per minute. right? So outflow valve will be fully open, there will be no residual cabin pressure. Automatic transfer of the system takes place after almost 70 seconds. After 55 seconds after the landing, your outflow valve fully opens to remove all the pressure inside. And after 70 seconds, if the CPC1 was working, then it changes to CPC2. And if CPC2 was working, then it changes from the CPC1 to the CPC1, right? Now during takeoff, to avoid any pressure surge or bump at rotation, the cabin is pre-pressurized when the thrust levers are advanced. Do you remember that this CPC takes information from the thrust lever angle also, from the EIU, thrust lever angle from the EIU. Either aircraft is on the ground or in flight, this information is taken from the LGCIU. The destination QNH or field elevation is taken from the FMGC, and static pressure and baro reference are taken from the ADIRS, right? So if the aircraft gives the full thrust, the thrust levers are advanced, the aircraft pre-pressurizes itself to 0.1 psi to avoid any pressure surges or bump at rotation during cruise. Now during cruise, the CPC maintains cabin altitude at the level of value or the landing elevation, whichever is higher, right? Now during descent, the controller maintains the cabin rate of descent so that the cabin pressure equals to the landing field pressure just before the landing. The maximum rate of descent is 750 feet per minute. Now you know everything how the automatic pressure control sequence on ground, during takeoff, during cruise, and during descent. Now there is one more condition over here. If in case the aircraft aborts the takeoff, then aircraft will not pressurize, definitely. In case of aircraft does not climb after takeoff or abort the mission, the abort mode prevents the cabin altitude from climbing. Cabin pressure is set to the takeoff altitude plus 1 psi. Keep it in mind. This is how your fully automatic pressure sequence works. Now you know how the fully automatic pressurization work, you know how the semi-automatic pressurization work, and you know how the manual backup works. Now I will give you some information about the system transfer of CPCs. During normal operations, one system is active, another one is on standby mode. Either one is working, another one will be on standby. If one fails, then other one will automatically take over. If the crew suspects any system to be malfunctioning, they can transfer one CPC to another CPC. How? By pressing this push button. Just a second. If flight crew wants to change system 1 to system 2 or system 2 to system 1, then press this mode cell push button, wait for 10 seconds and return again it to auto. This will change one controller to another controller, right? This is how system transfer takes place. Now in this video I have explained almost everything. If you want to watch this system, if you want to know more about this system, you can go and check out the fully FCOM explanation of this system. So thank you very much guys, I hope you liked the video.